So it's a pleasure to be here at Build, and I really appreciate the time and attention that you're spending with us. This is very exciting, Azure Data Explore. We launched it on February, just 3 months ago, and we're seeing a lot of growth. So this is a good opportunity to talk to you about, in general, how we are building large-scale analytical applications at Microsoft and with customers. So just before we start, who is a developer in the audience? Awesome. And who is an architect or a, okay. Who works for a software company? Who works for a non-software company? Okay, so it's almost half and half, and some hands are actually the same. So I raised twice. So, but that's actually a good hint to where we are going with this, because we're talking about how our companies, practically all companies, are becoming software companies in a sense. My name is Uri Barash, and I'm the Group Program Manager for Azure Data Explore. And we'll talk about building large-scale analytical applications for IoT, for apps, etc. And we're seeing customers folks dealing with the challenges that their business is behaving in ways that they do not understand or do not know. Questions like, what are my customers doing? What are they experiencing on my website? Are they enjoying my products? Are they not? Are my products working for them? Why are they happy? Why are they not? So in some cases, these are questions that they need an answer for within a single working day. For example, in mobile advertising, if you launch a campaign and you don't see the campaign picking up, you have to make changes immediately to that campaign. So we all want to be data-driven. What does it mean? When we're looking at how we're dealing with handling the workload of data, this type of the green data there was always there in computer systems since the 70s of the last century. Inventory, sales, etc. was always there. Now, when advertising and when Web 2.0 came along, we had to bump up our ability to deal with it. And when the purple wave of big data with sensors and social and so many things instrumenting and generating a lot of traffic, we had to rethink our approach in general. Two interesting things that are related to this. Things are changing very rapidly. New types of rows, new types of columns, a lot of expressiveness, new vendors, new versions of devices. The data changes constantly. And that means that a lot of folks are pushing data and encoding values inside text fields, inside JSON fields, just so they don't need to change their pipelines constantly. Another aspect is that we used to aggregate the data as it comes in because it was cheaper for us to save it. It was easier for us to manage it. But the challenge is that we are getting new decisions that we need to make almost on a daily basis. And pre-aggregating the data in advance does not work anymore. So what we're doing is just dumping the data all up in storage and aggregate it as needed on demand. The last element is that we are expecting more and more people in the workforce to be data-driven, to make data-driven decisions. And that brings us into the concept of the digital transformation. What is the digital transformation? Everyone's talking about it, but what is it? Practically, it's about every company sensing everything that's happening with its customers, with its employees, with the marketplace, with the weather, practically sensing all this ambient noise, sometimes business-related, sometimes secondary to the business, but still affecting the business. And the statement here means that actually every company needs to become aware of all this activity. When we're handling that activity in our systems, there are three paths that we are taking. One is the hot path. In the hot path, we are responding very quickly to events. We are doing this in a very short time period with low latency, but very little context responding to those events. On the other extreme, we put the events and the data that we are collecting into large log files, and we process them using MapReduce and batch technologies that are unlimited in size and capability, but very often take a long time. In the middle, we have the warm path, and the warm path is where we can look at the data as it comes in from seconds to weeks or months, and run ad hoc queries, ask every question that we want to ask, but still be able to look at massive amounts of information. What we've seen that's interesting is that groups that start using Azure Data Explorer actually move quite a lot of their hot workload into the warm path, because they can run much more interesting algorithms that take more context into account, be more accurate, and be able to reduce the false positives. We've seen teams like the Xbox teams that moved 95% of their data science workload from cold path to warm, because their data miners can be much more productive during the day. Instead of running a bad job every time they need to get an answer, they run small ad hoc queries that return immediately, and they can move very quickly during the day. One company that has faced these type of challenges and dealt with them in strong partnership with us is DocuSign. I'm honored to welcome Eric Fleischman, who's the CTO and architect in DocuSign. Thank you, Eric.
Of course. So is that working? All right, sounds good. So my name is Eric. We've been a Custo, or I guess I'm supposed to call it Azure Data Explorer. I'm not used to that name yet. We've been an Azure Data Explorer customer since pretty much the beginning. I emailed the head of the Azure Data Explorer engineering team just the other day to confirm that we were actually the first external customer outside of Microsoft. When we started down this path, we didn't really know what we were trying to do. We had an existing, here I'll open this up, let me just plug in. We had an existing telemetry system that was born out of a major investment that we did some number of years ago. DocuSign went down the path of, DocuSign went down the path of building a highly reliable platform that everyone could bet their digital transactions on top of, whether it's real estate agreements or other sorts of transactions that people do on a daily basis. And so we wanted to go down the path of building the most reliable platform we could. And so we made a major investment in telemetry in a broad sense. We had all these different data flows, and this is sort of a view of the last 24 hours. We're ingesting about 15 million metrics per second, and I don't know, what is this, about 31,000 events per second through our pipeline. And this is data that we use to tell the story of how is this platform working and is it reliable. When we met the first time back in, I think it was April of 2016, with the then Custo, now Azure Data Explorer team, we almost didn't know what we were getting. We didn't know what we were trying to do. We heard that they had a fast query technology. We were running on top of Hadoop and a bunch of other things we had stitched together. And so we said, let's give it a try. We invested a tremendous amount of energy and time into this, a sum total of 4.5 hours of one engineer's time, because we were like, we don't really know, this thing is new, we didn't really know what we were getting. And we have a developer on our team who focuses on telemetry and live site views of the system. And that's all he does. And he sent out this mail that was amazing, very much understating what he had done. He spent, as I said, the grand total of 4.5 hours on this integration. And he sent an email to a few of us and just said, hey, it was 7:15 at night. Hey, I did this thing, and here's what it is, and it's wired up, and only this small set of people has access to it. We're an engineering-driven culture, and so of course at 7:15 at night, that's like lunchtime for most of my team. So they of course started to poke at it. First reply comes at 8:03 p.m., which was absolutely amazing. And in fact, we got a bunch of quotes off the team. I went through my old email and fished out sort of what the team's perspective was on this. These were all things that people said in the first like 24 to 48 hours. If you saw our original queries, you'd realize we knew absolutely nothing about how this thing worked. But for us, this was game-changing. We were able to go from a world where we were running batch jobs, where queries were taking minutes, tens of minutes, in some instances hours at a time, and these results were coming back to us in 1, 2, 3 seconds. Now for us, we're, as I said, an engineering-driven culture. We're predominantly, if I could hit the right button, we're predominantly engineers that are kind of driving the system all day, every day. And so if we look at how people are using it over the last 24 hours, we've done 135,000 queries against the system. Perhaps more interesting is sort of when it's happening. Let's see if I can get this to work. Started on, if I can move the mouse, 5 minutes. Render line chart. In fact, as we run the system today, this is sort of a 24-hour view of queries running against the system. A pretty flat curve in the grand scheme of things. But if we start to take apart what people are doing with it, let's sort of do count, and let's say how long they take. We'll do percentiles, if I could spell, of duration. We'll say 50, 90, 95th, 99. By bin started on, I don't know, 1 hour. Order by started on ascending. And if we sort of start to take apart how people are using the system, our queries run really fast. Our sort of median query execution time, actually far below a second, about half a second, sometimes a third of a second. And so for our engineering team to go from a world where they were kind of running batch jobs to get customer insight to a world where the queries were just coming back as quickly as they could hit enter. In fact, the number one complaint we got about perf was that our original user experience, the HTML rendering was too slow. The query engine was far faster than the ability to render the results, which was sort of an interesting complaint from a team that was previously running queries in an hour. Two things happened that we didn't expect. Number one was we just had a lot more queries that started hitting the system. But number two is the number of people around our engineering team that started looking for customer insight, that were sort of driving the system to understand, is it behaving or not? We went from a world where dozens of people were kind of studying the site on a daily basis to overnight 350 or 400 people just driving the system really hard. We didn't understand how much perf, if you will, was the P0 for us, that if we could just make the queries faster, that in fact more and more people would drive the system. So for us, the partnership with the Azure Data Explorer team has been huge. And in fact, the technology sort of understates the work that we've done together, which has been great. So I'll be here after if people have questions, but that's been our experience anyway.
Eric, thank you so much. So a little bit, that was really phenomenal experience. And I'll tell you a little bit about the product, and then we'll put things in context. It's a fully managed, optimized for streaming data, interactive platform that supports ad hoc exploration, but also dashboard and application building, etc. And I'll show the scenarios in a second. And when we're thinking about what is it exactly, we're talking about an append-only database that deals with big data, high velocity, high volume, high variety, including JSON and text, and etc. It provides the very familiar notion of a database, tables, columns, etc. And it supports all the filtering joins, aggregated columns, everything you can expect from a relational interface to a data store. But it also includes full text search built in with text manipulation, time series capabilities, and the ability to run distributed Python and other languages very near the data. And we'll demo that very soon. Fully managed on Azure, and comes pretty much without no tables or structure. It's for you to, just like any other database, it's for you to fill in the structure of data that you are interested in. As opposed to other products in this domain that were initially designed as a search engine for online stores, this was actually built for big data analytics. It was designed for that, and it shows. And we consistently optimize for interactivity, and you've seen this, like the way Eric showed it, and you'll see this also in the other demos. Just a little bit on architecture. With Azure Data Explorer, you can ingest data from a very large variety of sources, from Event Hub, IoT Hub, listening to the data lake via REST APIs, client libraries, Azure Data Factory, from a Spark connector, from Logstash, from Kafka, etc. Quite a large variety of ways to pull data in. On the other hand, you can query the data using Power BI with direct query and get data. You can use other visualization tools that connect to the data via TDS endpoint, the SQL endpoint, so it behaves like a SQL server. From Jupyter Notebooks, from Grafana that has a native connector, from Spark, you can run batch job from Spark on the data in Azure Data Explorer, etc. So this is also expanding very quickly. And talking a little bit about how it's working, every piece of data that comes into Azure Data Explorer, it gets compressed, it gets indexed, and gets stored both on the local SSD of the engine machines that have just ingested the data, and also on the blob store for persistency. And when a query is executed, the query is distributed across the different servers that are powering the cluster. The results are aggregated and returned to the user, and this is how we get this accelerated speed. Just to summarize, the combination of metrics, time series, text search and analysis, and the relational manipulation that ties them all together is pretty unique in the industry. The query language that you've seen has received incredibly good feedback, and in general, this is typically about a third of an equivalent SQL query, and it supports IntelliSense in a very good way, and the ability to ingest data very, very quickly, almost in unlimited capacity, because it's an append only. We don't lock, so we can scale out the cluster as needed in order to support the incoming rate that's needed. And we have databases that are ingesting data almost in a half a petabyte per day, a single database. The last point that I want to cover is a very intrinsic element of big data, which is cost. When we're talking about big data, reducing the cost and keeping the cost very connected to the cost of operating the service is crucial, because then you can both be financially feasible for your customers and not lose money, which is also pretty important. Now, this is just an example. This is a 5 terabyte per day system that keeps the data in hot storage for queries like you've seen with a total of 30 days of retention of the data, and it costs about like $6,000 a month, which when you compare it to other solutions in the marketplace, for a fully managed solution that runs in the cloud, it's a very, very competitive offering. In terms of the pricing model, it's cost plus. So practically we bypass the cost of the hardware that we use in order to run the service, and we take a service cost on top of that. So with that, I hope you got a very short overview of what is the product and what it does. I'd like to invite Robert Peck from BASF. BASF is the largest chemical company in the world, and Robert is here graciously. You saw him in the discussion in the session by Rohan, the session on data. But welcome, Robert.
Thank you. As Uri mentioned, BASF has kind of massive assets around that produce chemicals around the world. And throughout these assets, we collect data, an estimate around 20 million sensors that record things like temperature, pressure, things like that. And so far, we had to, especially as Uri mentioned, kind of aggregate the data beforehand and run our analysis on that. And there are certain aspects that kind of get lost in this aggregation. And using Azure Data Explorer, we're now able to do this in a more, much more accurate and much more performant session. And what you're seeing here is kind of an application that we've built based on top of Azure Data Explorer. I hope that I can get the context across quick enough. So what we see here is essentially the reduction of hundreds of signals that we collect inside a single production plant, reduced to 4 scores. Especially on the bottom, you see that we can nicely distinguish 2 levels. And in essence, what we try to do is, from decades of data sometimes, extract several distinct operational states that we can then analyze and dive deeper into. And here, we've done just that. And we use high accuracy data on a minute or even second resolution to do this. Then, going even a bit deeper, this plot, and I probably have to explain a little bit what we're seeing here. So when we talk about trains, so these would be kind of distinct sections within a chemical production plant. And we run some fairly advanced analytics on that, and we run these analytics directly inside Azure Data Explorer. For this, we use built-in time series functionality. There's anomaly detection, seasonality decomposition, and there is built-in functionality to run custom Python code. And we use a combination of all of this to generate some insights. And let me just kind of explain a little bit of what we're seeing here. Essentially, the grayed out areas are areas of inactivity within the plant. And it may seem trivial to discern inactivity, but a sensor records whether a plant is running or not. And you sometimes have to talk to the experts, to the operators of the plant for significant amounts of time to discern, to derive rules that allow you to even arrive at that statements, are we active or not? And we can do this more or less in an automated fashion now by just analyzing the entire data set, running some classification algorithm on that, and arriving at that. So that's the grayed out parts. Now we're looking at the red parts. The red parts, the red lines, are distinct events that we detect occurring in the plant. These events might be disturbances that then propagate throughout our production. And these events are quite rare. So if you want to do learning on these events, we have to detect a lot of them. Otherwise, kind of the training doesn't make much sense. So we need to analyze long periods of time of data. On the other hand, these events sometimes happen on rather rapid timescales. So they may happen within minutes. So you need to analyze the time series at a high resolution. And that's what I meant with the previous aggregation. If you do that, you lose information about these events. So using Azure Data Explorer, we're now able to analyze these events. And this essentially gives us information about how information propagates through these plants. And well, we can learn a lot from that. Yeah. So again, if you want to dive deeper into this, I'm available as well. It will probably get technical. Bottom line is we can do a lot of nice things now. We're very happy with the product. Thank you. Yes, we can look for certain patterns. Yes. Yeah.
Robert is actually driving the envelope in terms of like applying analytics, but also machine learning and data science in order to optimize a very broad activity of a chemical plant to keep the world like cleaner and BASF more profitable, which is also good. So let's move forward. When we're talking about like what people are doing with Azure Data Explorer and how they're building these like applications that decrease the lag of the digital feedback loop, Then we've seen how DocuSign is doing this for creating a broad framework for telemetry collection and query execution, so that visibility for every type of information that the company does is actually available for people to analyze and leverage and drive insights from. And we have quite a few customers that are doing this. This is what I would call the first level of value, and this is also what we've seen at Microsoft. At Microsoft, we're ingesting about like 14 petabytes of data a day in order to drive these type of scenarios. Practically running on more than 500,000 CPUs in that workload just internally at Microsoft. The other thing that's happening is that some companies are providing solutions in those domains. And I'll talk a little bit about the solutions Microsoft is creating, but we have actually external customers that are providing analytical solutions for their customers that are implemented on top of Azure Data Explorer as a backend. And Siemens and Ecolab and Bueller are providing like visibility into the devices that they're selling to their customers, whether it's swimming pools, chocolate making machines, or MRI machines, but providing their customers with visibility into what's happening with those devices that are operating. And the more advanced scenario is how people take this and take the next step and apply data science and machine learning. And we have quite a lot of scenarios like that internally at Microsoft. And Robert with BASF is also another very good example of that. So for the solutions that we sell at Microsoft, then we have quite a lot of products that are built on Azure Data Explorer, Azure Monitor, Log Analytics, and Application Insights. The security products from Microsoft are all built on Data Explorer as a backend for threat analysis, detection, and hunting. The entire IoT stack, Time Series Insight, the Connected Vehicles platform, IoT Central, are all built on that on Azure Data Explorer as a backend as well. And the new Azure PlayFab that just was announced is using that in order to support game developers. They build like digital experiences for their customers. And there is a question that typically comes up, like when do I use the solutions that are built on Azure Data Explorer? When do I use Azure Data Explorer itself? And the answer is like, if you can use the solutions that where people have built like value, content, UI, algorithms, and actually implemented scenarios for you, then you should definitely go up the stack and use the most upper level product that you can use. But in case you decide to build your own and wants to have like more flexibility in how you organize the data and how you collaborate across different workloads, then Azure Data Explorer is a good platform to build on, and this is what the companies that we saw earlier did. So when we're talking about analytics, the data lake is a crucial element in the analytics world. The data lake is pretty much the heart of the analytics because this is where the data lives. And Azure Data Explorer works with the data lake in two ways, and I'll explain it. But in general, the data lake has evolved, and we've launched Azure Data Lake Gen 2 together, by the way, with Azure Data Explorer on February 7th. And it provides we see the data coming in from the left via either streaming technologies or via batch technologies like Data Factory, being stored at the data lake or being streamed directly into Azure Data Explorer, and then either written back into the data lake in an organized format or being queried by the modern data warehouse pattern with Databricks that does an ETL on the data and uploads it into in that domain. But now we are actually 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 in that domain, 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 but now we are actually we actually have one service that has two types of like interfaces to it. One is the blob store that we are all familiar with and worked with for a long time. It's working for Microsoft for more than a decade. And the new ADLS Gen 2 way of doing things adds file system, it adds POSIX ACLs, and it adds a lot of like functionality that was kind of like heavily requested by customers to support the big data workloads. The two services are currently working slightly separately, but in the next months you'll see them converging, so you'll be able to use the same storage via both APIs, via the two interfaces, and that will also light up all the existing integration that exists with Azure Blob Store. Will start lighting up on Azure Data Lake Gen 2. The end result is that by the end of the beginning of calendar year 2020, you'll see them like fully integrated and fully interoperable. So what does Azure Data Explorer does with the data lake? Multiple things. First, it's highly integrated with the data lake. It can ingest from the data lake. It can do it via Azure Data Factory, or it can do it via listening on the data lake and ingesting data as it comes in. And we've done that for a while now. The new things is that even when you stream data directly into Azure Data Explorer from IoT Hub or Event Hub or other means, Azure Data Explorer actually knows how to take the data that's streaming in, organize it in CSV or Parquet formats, and write it in an orderly fashion into the data lake, eliminating the need for other ETL processes that run in addition in order to organize the data. Yoni here will demonstrate that in a second. This is something that for IoT analytical apps that gets stream data and requires the real-time aspect of the data, but still would like to have the data available for other means, and that's a very valuable feature. And the last feature that we are practically announcing this week is that with Azure Data Explorer, usually we are working against an intermediate, an internal format that's highly optimized to provide the performance that we've seen. But in many cases, you also want to query out to the data lake for data that you have not ingested yet. And we are enabling today the concept of external tables where you can actually join data or union data that's hosted in Azure Data Explorer in the optimized format that provides the performance that you've seen with data in its natural format in the lake, whether it's CSV or Parquet, etc. And by that, Yoni is a developer in our product team. To you, Yoni.
Hi, everyone. It's a pleasure for me to be able to show you some of the stuff we've been talking about. Let's dive into some demos and see what Azure Data Explorer can do for you. So the data set I'm going to use today is the data set of the last almost 3.5 years of events from GitHub. Basically, each time someone commits code into GitHub, watches a repository, adds a comment, opens up an issue, there's event persisted in a GitHub stream, and we have been collecting these events in the past 3 years until these last few seconds, and continuously storing them in Azure Data Explorer. So what we have is a database called GitHub, in which we have a table, As you can see, it has almost 1.4 billion events starting 2016 and up to a few seconds ago. And this is a UTC timestamp over here. In terms of size, we have approximately 3.5 terabytes of data, which I would consider like a medium size. We've seen much more being handled by Azure Data Explorer pretty easily. Let's look a little bit about how the data looks like. So we have 15 categories of different events. As you can see, the push events are the most prevalent ones, with 727 million ones since 2016. We have create events, watch events, pull request events, you name it, everything is indexed, compressed, and fully available to query in this Azure Data Explorer database. How does the schema look like? Well, we have all sorts of different columns. We have longs, we have strings, we have booleans, datetime, basically any numeral value is also supported. And we have a special type which we call dynamic, which is semi-structured data in the form of JSON, which is very familiar, I'm assuming, to most of you. Here's an example of how this JSON payload looks like. So for each kind of different event, it has a different schema. So for example, for a push event, you have a distinct size, you have an array of commits, you have the push ID, some kind of reference, et cetera, properties. For a watch event, you only have a single property, which is action. For issue events, the payload is slightly differently. So as you can see, it's not a fixed schema, but everything is stored efficiently within the Azure Data Explorer and allows us to reason about the data fairly quickly and get insights. So let's try and do some of that. What this next query is going to do is actually look for repos, which is, again, a JSON field, and then filter names which have the word Microsoft in them. Okay, so what I'm doing is I'm counting the top repos which have the name Microsoft in them and taking the top 5. As we can see, VS Code and TypeScript are among the 2 more prevalent ones in the last 3 years, with CNTK, F#, and VSTS tasks coming in 3, 4, and 5. And I'm going to dive into the first 2 ones, which are VS Code and TypeScript, and try to reason about the trend of growth or not for these 2 technologies in the last several years. So as you can see in this query, which, by the way, returns in under half a second, performance is pretty much amazing. I'm filtering for these 2 repositories in the 3-year plus time frame. And I'm actually using linear regression, which is a built-in operator for time series analysis, and plotting a trend line for both VS Code and TypeScript. So we can see VS Code is gaining popularity like in a steady state, but still growing, whereas TypeScript, while still popular, remains pretty stable in the past couple of years. So trends are always fun to look at, and this is like one example. A different example is like if you open technology blogs and if you're an avid reader, then you've probably heard about terms like Ethereum, Spectre, Meltdown, GDPR, blockchain, Kubernetes in the past few years across the news. And what I'm doing actually in this query, I wrote like an inline function which tries to find the trend of these terms if they appear or not in the large payload of data for events in GitHub. So I'm actually looking for a specific term. The first one is Ethereum, the next one is Spectre, Meltdown, GDPR, and 2 other ones I'll add in a moment. And I'm actually counting the amount of occurrences of them on a weekly basis. And as you can see in the trend line plotted below, we actually can see 3 or 4 even nice anomalies. The first one is for Ethereum in March of 2017. The EEA, which is the Enterprise Ethereum Alliance, was announced. And that essentially created lots of volume of traffic in the GitHub service. The next one is, well, it's both Spectre and Meltdown, the security vulnerabilities in Intel processors, which were publicly announced in January 2018. So we can see these 2 bumps here, the first week of January 2018. And the third one, I'm pretty sure most of the people here have heard about GDPR, which went into effect on May last year, 2018. As we can see, lots of people probably left the work the last couple of days or months. And there was a large spike of traffic occurring over there. Let me just edit this query and add blockchain and Kubernetes, which are also very popular technologies in the past years. And you can see they actually take the stage with Kubernetes gaining popularity over all the rest of them, and blockchain pretty much aligning with the trend we've seen for Ethereum. So querying the data and writing queries is very fun, and we have built-in IntelliSense and a very rich and powerful query language, but sometimes you want to take your query and persist it and just put it to rest and just look at it every couple of hours, minutes, or seconds if you're a real addict. What we have here is a dashboard built using Grafana, which is one of the visualization solutions we offer you to use for dashboards and visualization. This is a live dashboard feeding from events continuously being ingested into the same cluster I was just running queries against. You can see the latency is practically a couple of seconds since the last event was ingested into the cluster. You can also see like a trend of the popularity of each type of event, with push events being the most prevalent ones. There are like 55% of events in the last hour. And we can also see the top 10 most active repos in the last hour, and the top 10 popular languages today, with JavaScript coming in first, Python second, and all the rest coming after them. As already mentioned, we're now exposing new capabilities in Azure Data Explorer, one of which is continuously exporting the data into the lake. So as data comes into the cluster I've been querying and configuring my dashboard against, we've been continuously exporting the new data into the lake in one setup and continuously running manner. And I can now go into ADLS Gen 2 and see all the data, whether it's historical data from 2016, it's sorted by month and by day, and it's stored in CSV format. So I can just dive into a specific day and look at the file explicitly. And I can also look at more recent files from today is May 7th. So we probably have files here from a couple of minutes ago. So this is like 2:41, 3 minutes ago. So it's continuously being exported into the lake and available for using it from there, whether it's in Azure Data Explorer or in other services. Now, we mentioned we're now announcing a new functionality in preview, which is called an external table. So what I have in this cluster is an external table which is actually configured against the same stream I've just shown you. Okay, so it has a connection string to ADLS Gen 2 to a specific file system, which has all these events I've just shown you in the Storage Explorer. And the query I'm about to run now actually takes the last month of events, GitHub events, which we have ingested into Azure Data Explorer, and actually joins them with an aggregation over the same month last year, 2018, which is only in the lake. It's not ingested into Azure Data Explorer. So I have the live stream of events in the last month. I'm filtering it for the top 10 languages which we've seen in the dashboard, counting events by language, then joining that with the same month coming from the data lake directly and running that. I would expect the performance to be slightly less efficient than if all the data was available in ADX, but it still allows me to reason about the data in an interactive manner. You see, it took 10.6 seconds to get all these events for a whole month directly from the lake, join that with 30 days of data which are ingested, and I can see the trend of, for example, JavaScript. The purple line is last year, the blue line is this year, and I can actually reason about the trends. I see JavaScript is maintaining its popularity, and others are slightly afterwards. Another query I want to show is not only over a period of 30 days of data, but actually the entire 3 years of data coming directly from the lake. What I'm going to do is use the external table, filter to the data set of 3 years, look only at pull request events, and then count the number of events per week, and try to plot a trend line to see how these are growing over time. Again, all this data is not ingested into ADX. It's coming directly from ADLS Gen 2. And as you can see, the query over 3 years of data returned within 19 seconds and shows me a nice trend line of the amount of events per language. The dips, by the way, are holiday seasons in December, which makes sense because we can't work all the time. With that, back to you, Uri.
Thanks, Yoni. This is actually really, really exciting because it allows us to combine the set of capabilities that are constantly requested and really are helping people to make sense out of the data. So, but going beyond the data, just like we've seen on the scenarios for ML, we're enabling. No, that's the other way. So the data science and machine learning capabilities are also very, very demanded today. And Azure Data Explore comes out of the box with the ability to do anomaly detection and clustering and forecasting regressions and these kind of things. And they are used very heavily, by the way, also as part of Azure Monitor, Log Analytics, and the other products. And that comes out of the box as ready-to-go functions that are available. But in addition, we are now taking it out to public preview, the capability of running the Python code in a distributed manner, in line with the query language itself. And I'll talk a little bit about it after we complete the list of features, because introducing Spark connectors, and we've done that over the last couple of months, we're actually enabling people who run jobs on Spark to run the job directly on data in Data Explorer, get the data, push the predicates down into Azure Data Explorer, get the relevant data out, run a model, upload the model back into Azure Data Explorer, and then using technologies that we call like update policies that allows running logic on every piece of data that comes in, you can actually do the scoring of the model that you've computed in Spark inside Azure Data Explorer on the data as it comes in, enriching it and making it available for all your analytic needs, and also when you are later ongoing exporting it to the data lake. And the last thing is Azure Data Explorer is completely integrated with the Azure Notebook, Jupyter Notebook, with a concept called KQL Magic that allows you to run queries directly against Azure Data Explorer from notebooks, so data scientists feel right at home doing that. And I'd like to welcome Avner, who is a product manager in our team. Welcome. And Avner is going to demonstrate a machine learning exercise that a fellow professor in Technion, one of the university, the top technical university in Israel, has been like teaching his class. And you can see how this is done with Azure Data Explorer.
Hear me?
Yes.
Okay. As Uri said, the demo that I'm going to show is from a question that my friend that is teaching the Introduction to Machine Learning course in the Technion University in Israel, Dr. Daniel Sudri, with his PhD student, Omer Yair, give to the students. And the question is that based on the New York taxi rides data set, what are the best places to place parking lots within New York City in order to minimize the taxi ride's length? For this, we created this Azure Jupyter Notebook, and as Uri said, we are using here the KQL Magic package that allows us to easily interact with the Azure Data Explorer cluster where we have this data set. So after connecting into the cluster, the first query that I'm going to run, or that I'm running here, is to count how many rides I have in my data set, and the result here is 177 million rides. The next thing that I'm doing is to plot the number of rides per week. And you can see that I'm not using any plotting library of Python here. I'm just, the KQL Magic package itself knows how to plot the results within the Jupyter Notebook. The next query is returning a sample of the data. And you can see that there are The data that we're returning is 3 records. It has the pickup time and the pickup location and the drop-off time and the drop-off location. And the next query that I'm doing is to bring back all the pickup locations that I have in my data sets back to the notebook. And using the matplotlib library of Python, I'm going to place a white dot for every pickup location on a black canvas. And the result is this drawing that is drawn by those white dots. And you can clearly see the shape of the New York City there, with the brightest spots is in Lower Manhattan, where most of the taxi rides are happening. You can see also the Central Park, the dark area in the middle. And on the right-hand side, you can see the LaGuardia Airport. There's a bright spot over there. And on the lower right, you can see the JFK Airport. OK, so now you can see where those taxi rides are happening. So the next thing to do is to find the places for the parking lot. For this, we're going to use a k-means algorithm that does not exist natively in Azure Data Explorer. So in order to calculate that, we will need to use Python. So the first query that I'm doing is going to bring a sample of the data. Only 0.1% of the data, which is 177,000 rows. I'm going to bring them locally into my notebook and run this Python code here that does the k-means scoring and clustering. And it will bring me back 8 locations for those parking lots. Those are the results. And when I plot them back on the same heat map, I can see those pink stars where the size of the star is proportional to the size of the parking lot that I need to use over there. So this is good because it's somehow the solution, but it doesn't run on the full data set. It only runs on 0.1% of it. And what I really want to do is to run it on a full data set. For this, I'm going to use the Python plugin, which we talked about, which is the ability to run Python within our Azure Data Explorer query. And the way that we run it is we run it in sandboxes that are running in a distributed manner. In this case, we're using 64 sandboxes of them, distributing that over the different nodes of the cluster. And those queries are running close to the data, and this whole query returns with less than a minute. It brings me back a new data set of where the parking lot should be. In this case, I'm using these yellow stars to show you where those locations are. So for summary, there is 2 features here that I use that are allowing me to work with Python. One is the Azure Jupyter Notebooks integration, and the second is the ability to run Python code within Azure Data Explorer query in a distributed manner close to the data. Thank you. Back to you, Ori.
Thanks, Avner. So that was like optimizing where taxis should park in New York. So we really reach every type of like scenario with this. So just to summarize, we've seen how Azure Data Explorer is used to build internal applications to optimize how a company senses the information around it and runs on it. And we've seen how software companies and companies that sell products that need associated analytics with it are actually productizing products based on services and products based on Azure Data Explorer. And there are a few links here that are available as part of the build framework to actually go and read about Azure Data Explorer, access to all the links. You also have this in the material that we've made available near the entrance. And I'd like to invite you for a beer night with the Azure Data Explorer expert that we're holding at the Tap House, just like 3 minutes away from here tonight after 6. We'll probably talk about like data analytics, so it's not like, but it's still like, it's going to be like, they have quite a lot of beers. So, and you are welcome to come over to our booth and have discussions about, is this relevant for you and is this applicable? And we are, just like in the case of BASF, that are using a broad variety of Azure products like Cosmos DB, Databricks, Azure Data Explorer, and the data lake. We actually know how to frame things in the broader context, so lean on us. And yeah, this query like aka.ms/adx.b19 returns the list of sessions that reference ADX, and you can actually query it and play with it as well because it's running on our help cluster. So with that, I'd love to hear more if you have any questions, etc. That would be good time. If there are no questions, that's fine, but feel free. Yeah, go for it. Ken. Yeah, please do.
So two quick questions. Oh, there you go.
Awesome.
Is there I know that there's a unified API coming for blob storage and data lake ADLS Gen 2. Is there an advantage to using one over the other in the context of ADX?
So actually, the more accurate way to put it is storage is one service. It will have two APIs, the Azure Blob Storage API and the Azure Data Lake Gen 2 API. And they will offer different functionalities based on the API. If you go via the Azure Data Lake Gen 2 API, then you'll have the POSIX ACLs, you'll have the file system capabilities, etc. But it will still support the Blob Store existing APIs going forward. So the performance will be the same. It's going to be the same service.
Okay. And then second question, I'm sure most of the demos are built on tables or files rather with many rows but narrow, not a lot of columns. What about files like CSV files with hundreds or even 1,000 columns or so?
We've had tables with thousands of columns. I don't know what the limitation is, like 10,000 or something like that. But what we recommend typically, and you've seen how the Git data is organized, the Git data is actually like 6 columns, but within like the actor column, they have like about like 20 different attributes within that. So we actually, what attributes of the record your queries are actually using. So the ones that are using, you typically promote them to be a standalone field. For the ones that are used less, you actually keep them in a JSON object, dynamic object inside the array. Depends on how your data is structured. This is like your flexibility.
Okay, I'll come to the booth and talk in more detail. Thank you.
Awesome. Go for it. Thank you very much. Oh, go ahead.
This sounds like a newbie question because we're exploring the data lake as well, and we kind of don't know what's the best practice on how to store or structure the data. So our scenario is we want to store per transaction. So do you want us to bulk it up first and then store it as 1 day worth of CSV file, or what's the best practice on that one?
I don't think there is a single answer for that. I think that it's more dependent on the scenario that you're trying to run. It depends on the volume of data, the rate of data coming in, and what kind of queries and the latency that you expect from your data. Mm-hmm. So it's kind of hard for me to give a general answer.
Can we just store one record per file? Or?
So one record per file is probably not a good idea. Yeah. But it really depends on the latency. Sometimes, if you really care about the latency of data, then you might have situation, for example, if your application runs overnight and in the night there is less activity, you might have less data in specific files. It really depends on your application. I'd love to have, to take this offline with you and talk about this, in your case.
All right, thanks.
Thanks.
questions. First, if I want to give it a try and I have a few Parquet files data that I want to try, what's the ingestion mechanism that you would recommend to just try the service?
So one of the easiest ways to do it is using Azure Data Factory, because it can take data from everywhere and upload it to Azure Data Explorer. You can also ingest one file individually in a command directly from blob or ADLS. This is also a possibility. You can also upload a local file from a machine from the FAT client that actually knows how to upload files. This is another way.
And yeah, actually,
Yes, it's him.
Yesterday. And by the way, I just saw that you published the white paper, and thank you for that because it's really interesting. The other question was, can you join between two sets of data, either to, I don't know how you called it, the storage, is it a table or is it a
we know how to query out to Cosmos DB, to SQL servers, to the data lake, and internally, naturally, and also via REST APIs to many other places as well. And you can join across all these data sets because we don't require a referential relationship between table. All the schema is on read. You can actually join whatever you like across the data set, given that they're not huge. Because if you're going to query out for a SQL server and asking for a petabyte of data back, it'll take time.
Yeah, because of SQL Server.
Networking, many excuses, yes, definitely.
Thank you.
Yeah, thanks. Thank you.